Good morning. I am getting set up for my Algebra 1 video. Good morning, everyone. Y'all tell me if that looks clear. If it looks clear, just give me a thumbs up or a like. Let me see if I can see it on my end. Today we're going to be multiplying radicals. By now y'all should have completed lesson 1 and lesson 2, which taught you how to simplify radicals. And I'm still going to wait for a few more minutes to see if anyone else is going to join. So I'm just going to sit here, look at my computer screen, and see if I can see this video to see how it looks. Remember, following the live lesson, I will be posting this video to YouTube. It'll also stay on this page, you know, if you need to go back. And look at it here, but I'm going to post it to YouTube also. Alright, I've got it set up on my screen just so I can glance at it every once in a while, make sure that it's all in view. It'll also stay on this page, you know, if you need to go back. I gotta mute that. That'll confuse me. Alright, let's go ahead and get started. Remember, if you don't get something, if I go too fast, I'm going to try not to go too fast. If I go too fast, you can always go back and look at it. At the end of this lesson, if anyone is really confused and needs like I was, you know, going to do a video call every Friday, but if you need an immediate video call after this, I did that yesterday with some of my students. I can call you and we can talk live and I can answer any questions. This is live, but it's just hard to communicate back and forth on Facebook because the comments are delayed. Alright, so let me move this just a little. Okay, so today's lesson, this is Algebra 1. This is for 6th and 7th periods. We are multiplying radicals. Today's April the 7th. I'm pretty sure. Because it's hard to keep up with the days now. Goal. Our goal is to multiply 2 radicals together and then write the answer in simplest form. Write the answer in simplest form is what we did in lesson 1 and lesson 2. So we have just one other step to add before that. So that's why it's so important that you did lesson 1 and lesson 2 before doing this. Multiplication property for radicals. This property kind of shows you the rule, which basically says that whenever you have 2 radicals, you just multiply whatever's on the inside, you just multiply that together and make one radical out of it. So that's what this is saying. The square root of A times the square root of B is the square root of AB. Okay, and we're going to show that with example 1. And I've written a few notes here so you can kind of go back and see what I wrote on the reasoning for this first example and the second example, just to let you see when to simplify. Example 1 says simplify the square root of 5 times the square root of 2. So they're both under the radical. All you do is multiply 5 times 2, which is 10, and so you get the square root of 10. Now that is your final answer. That's all you do to that one, because 10 does not have a perfect square in it that you pull out. So you just leave it there, and that's what I wrote here. Can 10 be divided by any of the perfect squares? And the answer to that is no. So the square root of 10 cannot be simplified. Now remember, the perfect squares, it may help you. I'm just going to, let me see if I can see this at the top. I'm just going to write at the top the perfect squares again. So whenever I say, can this be divided by a perfect square, you'll know what numbers I'm talking about. These are the ones I told you in lesson 1 that you needed to learn. So let's see, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and I'll just stop there. But those numbers are the ones that you're looking for to see if they're factors of the number inside the radical, and if they're not, none of those numbers are factors of 10, then you're done. You're finished. That's the square root of 10. That's the answer. All right, on to example 2. Simplify the square root of 10 times the square root of 2. So once again, we're going to multiply what's inside the radical, 10 times 2, which is 20. And we're just going to make a square root of 20. Now, this is not my final answer, because it says, can 20 be divided by a perfect square? It can. Which one of those numbers at the top, those perfect squares, can divide evenly into 20? It's 4. So we're going to factor 20 as the square root of 4 times 5. You don't want to use any other factors of 20, because you want to use the factors that have one of them has a perfect square. So now once you factored it, you take the square root of 4. I'm going to mark it out. That comes on the outside as a 2. And then you're left with your 5 on the inside. So 2 on the square root of 5, that is your final answer. So you can see that this part right here, the square root of 20, that's what we did in lesson 1. So that part's not new. The only new thing is multiplying them together to begin with. Alright, so now, this last example on this page, if you'll notice, A, B, C, and D, they're all written the same way. They've all got parentheses around the square root, and then it's raised to the second power. These are super easy. I went through on iExcel to make sure that I was going to cover everything that was in that lesson, and these were on there. And these are going to be easy. Hopefully you'll get like 3 or 4 of these in a row on your iExcel lesson. I'm going to show you on the first 2 the work that you have to do to get the answer, and then the second 2 you'll see how easy it is just to put the answer without any work. So on part A, you've got the square root of 6 in parentheses raised to the second power. Remember, when something is raised to the second power, you just multiply it by itself. So you're going to do the square root of 6 times the square root of 6. And the square root of 6 times the square root of 6 is the square root of 36. Well, 36 is a perfect square. It's one of those numbers that I wrote at the top. So you just take the square root of 36, which is 6, and that is your answer. Now notice this answer, and notice the problem. Okay, let's move on to part B. On part B, we've got the square root of 9 to the second power. So that means you've got the square root of 9 times the square root of 9, which is the square root of 81. Well, what is the square root of 81? It's 9. So the final answer is 9. Look at the answer and look at the problem. If you've noticed on part A and part B, it's always going to work out this way. Because when you square a square root, they just cancel each other out. That little 2 on the outside, the exponent, cancels out the square root symbol. And your answer is always going to be what's under the square root. Always. So look at part C. You've got the square root of 10x to the second, in parentheses, raised to the second power. Well, that second power cancels out the square root symbol because they're exact opposites. And your answer is just everything that's under the square root, 10x to the second. That's your answer. Can't get much easier than that. All right, part D. The square root of 14x to the fourth raised to the second power. Remember, the second power cancels out the square root, and your answer is just 14x to the fourth. So hopefully on your IXL, you'll have several of those that will let you increase your SMART score. Okay, I hope everybody's good with those first 3 examples. I'm going to move on to the next page of examples. And I do have quite a few here because, like I said, I went through your IXL lesson and I wanted just to make sure that you could do all the kind of problems that you'll have in that. So I've done a few examples. Hopefully you'll understand by the time I'm through with all these. The biggest thing about this lesson is to know your divisibility rules, factors of numbers, multiplication. If you're not good at that, it'll be a little difficult, but of course you can use calculators. Hopefully everybody's got a calculator on their phone. And I'm going to, that just hit me that I don't have my calculator with me, so I'm going to need my calculator. Hang on just a second. Now, these first few problems I don't, but there's a problem down there I can see that I'm going to need my calculator, so hang on just a second. All right, I've got it. So, example 4. Simplify the square root of 5n times the square root of 15n to the second. So again, both of these are under the square root, so we're going to multiply them together. And when you do that, you get the square root of 5 times 15, which is 75. Remember, when you multiply variables, we learned this already. When you multiply variables, you add the exponents. So this is n to the first times n to the second. You add the 1 plus 2 and get n to the third. Now, this, the square root of 75 n to the third, is exactly like problems we learned in lesson 2. So if you have any trouble from here on out in this problem, then refer back to lesson 2. We've got to find a perfect square that will divide into 75. I'm going to write the perfect squares up here again, and it will help you when you're doing your IXL to write these down so you'll have them in front of you. 4, 9, 16, 25, 36, 49, 81, 100, 121, 144, and they go up higher, but you won't have too many that have perfect squares higher than 144 that will divide into the number, I don't think, on your IXL lesson. Alright, so we're going to simplify the square root of 75 because one of these perfect squares does divide into 75, and it's 25. So we're going to factor 75 as 25 times 3. And then into the third, remember, if it's an odd exponent, you have to drop it down one below that, which is going to be n to the second, and you have to factor n to the third as n to the second times n. Because remember, only the even exponents are perfect squares with variables. So now you've got everything factored. You look at your perfect squares and you take the square root of those. So the square root of 25 comes out as 5. 3 is not a perfect square, so we leave it alone. N to the second is a perfect square because it's an even exponent. So you take the square root of n to the second by halving the exponent. Remember, when you halve something, cut it in half, divide it by 2. So we're going to divide 2 by 2, and you get n to the first. Then these two that I don't have marked out stay under the square root. So your final answer is 5n on the square root of 3n. All right, moving on to example 5. We're going to simplify 2 on the square root of 12f times the square root of 3. Now notice this problem has a 2 on the outside of the square root. If there were another number on this radical that on the outside, we would multiply those on the outside together. You can never cross over, like I could not multiply this 2 by anything under the square root. You can't cross over. So since there's no number in front of this square root, you're just going to leave your 2. So that's going to be 2 on the square root. And then you multiply 12 times 3, which is 36. And then you just write your f down because there's not another f to multiply. And then you look at your square root of 36 to decide if you can bring anything out. And 36 is a perfect square. It's one of those numbers up there. So remember, that whole thing comes out. You don't factor it. You just take the square root of it. So you're going to leave your 2 in front. You're going to take the square root of 36, which is 6. And then your f just stays under the square root. Multiply 2 times 6, which is 12. And you get 12 on the square root of f. And that is your final answer. Oh, I miss being able to have interaction with y'all. I would like to have y'all ask questions right now, but on this kind of video it doesn't really work well because I don't get your questions till later because it's so delayed. That's why whenever we go over this and you maybe look back at the video, if you're having any trouble, I will be glad to do some one-on-one through Skype or through the video call on Teams. Just message me and let me know if you need more help with it. All right, number 6, example 6. Here's our problem. The square root of 15x to the second w times the square root of 10x to the third. So I'm going to multiply 15 times 10. Which is the square root of 150. And then you multiply the x's together by adding their exponents. So x to the second times x to the third is x to the fifth. And then there's no other w to multiply with this w, so you just bring it down. Alright, so there's our square root that we've got to simplify. The square root of 150, x to the fifth, w. The reason I know I've got to simplify this is you have an exponent that's greater than 1. You can never have an exponent that's greater than 1 underneath the square root. You'll have to factor that. The 150 can be divided by 25. So we're going to factor 150. And y'all listen, let me show you something. If you don't know right off that it can be divided by a perfect square, just take your calculator. Let me show you something you can do. Just take your 150, whatever number's under the square root, and then start dividing it by those perfect squares. Like 150, you know pretty much it can't be divided by 100 or anything higher. So just start with your 81 and do 150 divided by 81, and if you get a whole number, then that means it can be divided by that perfect square. If you get a fraction or a decimal, then it can't be divided by that number. So move on down to 49, 150 divided by 49. That gives you a fraction. 150 divided by 36. That gives you a fraction. 150 divided by 25. And that gives you a whole number. So that lets you know that 25 times 6 is what you're going to factor it as. So I'm going to come under it, and I'm going to factor 150 as 25 times 6. And then your x to the 5th, remember, since that's an odd exponent, you have to drop it down 1 to x to the 4th. And then times that x to the 1st that's left over, because x to the 4th times x to the 1st is x to the 5th. And then times your w, and it has no exponent, so you just put times w. Then you look through, and every factor that's a perfect square, you have to take the square root of it and then bring that answer on the outside. So the square root of 25 is 5. 6 is not a perfect square. X to the 4th is a perfect square because it has an even exponent. Half the 4, and you get x to the 2nd. And x and w, those are not perfect squares. So you just now write down the square root with all these leftover numbers inside. 6x w. So your final answer is 5x to the 2nd on the square root of 6xw. All right. I'm looking to see who all joined. Wow. Hey, everybody. I even see some, I see a senior. Hey, Whitney. There's Nick Bryant. There's Blake. Both Blakes. Gabby. I miss y'all. Okay, example 7. If you're still having trouble knowing how to simplify, like after you multiply these and you're having trouble simplifying right here, like the 100 and 150, I can show you another method using a factor tree that you learned in middle school that will that might help if you're having trouble. So at the end of this video, I'll probably do a few problems to show you another way. You know, if looking at another way, if you have this and you don't really want to look at another way, if you think it will confuse you, you don't have to. But for some people, this is just really hard to simplify these numbers. So I do have another way that I can show you. All right, example 7. We're going to multiply. We have the square root of 2g h to the 5th times the square root of 105 g to the 5th h. So I'm going to multiply 2 times 105. Write all this under your square root. 2 times 105 is 210. And then we have this g times g to the 5th. Remember, you add the exponents and get g to the 6th. H to the 5th times h is h to the 6th. And now we have to simplify that. So we want to start with our 210, the square root of 210, and we want to see if any of those perfect squares at the top that I wrote down that you were supposed to have already learned, if any of those are factors of 210, if any of them will divide into 210. So let's start with 210. No, we'll just start up here with 121, because some of you might think that that is a factor. So remember, you get your calculator, put in the number that's under the radical, and just start dividing by those perfect squares. So 210 divided by 121 gives you a fraction, so it's not that one. And remember, the same thing, your calculator may give you a decimal. If it's a decimal, then that means it's not a factor. So 210 divided by 100, that is a fraction or a decimal. 210 divided by 81, that's a fraction. 210 divided by 49, and I'm not going to keep going. But if you do this all the way down, let me show you with 25, because a lot of people think 25 goes into it. 210 divided by 25 is a fraction. 210 divided by 4, that's a fraction. All of these perfect squares, if you try those, none of them are going to divide into 210. That means 210 is simplified, the square root of 210. There are factors of 210, but there's no perfect square factors of 210, so you can't do anything to that. All you can do is simplify the variables, because they have exponents, and so you have to simplify those. But luckily, they're both even numbers, so these are easy. You just half the exponents. So you can't take anything out of 210, but you can half your 6 on both of those, and you'll get g to the third, h to the third on the outside, and you're left with your 210 on the inside of your square root. So your answer is g to the third times h to the third on the square root of 210. All right, example 8. I'm going to move this a little bit. All right. So now we're going to do example 8. Simplify 5 on the square root of 28 x to the 5th y to the 3rd times the square root of 2x to the 2nd. Again, you have this 5 on the outside. That 5 can only multiply by another number on the outside of the second radical. Since there is no number to multiply by, that 5 just comes down. So you're going to have 5, and then your square root. Now multiply your 28 times 2, which is 56. We are going to simplify the square root of 56. X to the 7th, y to the 6 has a factor in it that is a perfect square. So you take your 56 and start dividing. Now let me tell y'all something. Some of you, it may pop up 7 times 8, because 7 times 8 is 56. But neither 7 perfect squares. So you've got 4. That's a perfect square. It comes on the outside. Now we've already got a 5. I'm going to run out of room. Square. So that comes on the outside as a 2. 14 is not a perfect square. Perfect square. So that's going to be times x to the 3rd. You half your exponent. X is not a perfect square. Y to the 2nd is, you have your exponent. It comes out as y to the 1st. Now you're left with the factors under the radical. 14xy. And then all you've got left to do is multiply your 5 times your 2. 5 times 2 is 10. So you get 10 x to the 3rd y on the square root of 14x y. And that is your answer. Oh, I just got blurry. I'm going to wait for a minute to see if it can clear up. Alright, hang on. I don't know how long it's been blurry. Let me try to fix it, and then I'll go over some of those. Someone tell me what example it went blurry on. Just type in which example it went blurry on, and I'll go back over that if I can get it to be clear. Oh, that looks like it's getting better. Can someone type in which example it went blurry on, please? It looks like it's... Let me move this around just a second. I think I'm still live. I'm trying to figure out if I'm still live. So y'all just bear with me. I don't want to end this video because then I'll have 2 videos and that'll be confusing. Can y'all still see me? I know it cut me off for a minute. Anybody still there? Blake, are you still there? Is it blurry or did it clear up? It looks like it might have cleared up. Blake, can you tell me which example that it went blurry on so I can see which ones I need to go back over? Let me go back over example 8. Maybe it wasn't blurry until then. Okay, you said example 8. So let me go back over example 8 then. Once you multiply 28 times 2 and you get 56, then multiply x to the 5th times x to the 2nd and you get x to the 7th, and then y to the 3rd. You have to simplify this. And when you simplify what's under the square root, you've got to use a factor of 56 that is a perfect square. 4 divides into 56, and it is a perfect square. So I factored 56 as 4 times 14. X to the 7th is the 6th. Drop that odd power down to 1, which is an even number. And you get x to the 6th times x. Your y to the 3rd has to drop down to y to the 2nd times y. Oh my gosh, it went blurry again. I'm sorry, my Wi-Fi is going in and out. Oh dear. Maybe it was clear long enough for you to see all of example 8, and you can go back and look at it and see what I was doing. Maybe it's me. Maybe if I get close to my phone, it's going out. Let me... Okay, so you got it all? That's good. I'm going to move on then to example 9. And it's our last one. But before I start it, I'm going to make sure that I can get it to where y'all can see. The joy of technology. Okay, that is still blurry. Well, y'all leave and then come back and see if it looks any plainer. Hey Tristan, are you there? When I was doing example 8, my Wi-Fi started acting crazy. So right now I'm just trying to get this clear so you can see the last example. Anyone still there? All right. There's no need to do this last example if you can't see it. So what I'm going to do then is just tell you what your IXL lesson is. And maybe the first 7 or 8 examples will be enough. The last one is the same thing. It's just a little bit harder than the others. Your lesson, y'all listen carefully because you can't see it. Your lesson for today is on IXL. It's under Algebra 1. It is EE4, EE4. And you have to get a SMART score of 70. Just 70 this time. Lesson EE4 on IXL. Get a SMART score of 70. And I'm sorry about my Wi-Fi. I'm sorry that I didn't get to finish that last example, but I showed you enough. You should be able to do it. It was just a little bit more practice with a harder problem. Remember, if you miss one, look at the reason you missed it, because they show you on iExcel, and then just go from there. Smart Score 70, EE4. So now you have 3 lessons that you have that I've given you. Lesson 1, which was EE1, lesson 2, which was EE2, and now this one, which is EE4. Send me an email if you need more help, and I'll try to get on a video call with you to help you live, if my Wi-Fi allows me. Thanks. I'll see y'all later. I miss y'all. Bye.